Welcome. So in this video we are going to discuss about a very efficient sorting algorithm. You might have heard it before. It is the quick sort algorithm. Now what does quick sort do? This quick sort sorts any array or list containing some integers, and it sorts it so efficiently that the time complexity is almost O n, big O of n, that is the time complexity is used by this specific quicksort method. Now in this quicksort there are several steps we need to consider. The first step is, first we check the length of the integers list or array. If it is less than 1, then we directly return it as it is. Check the length of numbers or list. Let's say here we are considering it as list. If it is less than 1, then we directly print it. Otherwise we compare it on the basis of the pivot. Compare it on the basis of pivot, or let's say pivot. So how this quicksort algorithm works: you can use quicksort in many use cases. You can use in any problem statements, like if you don't find a perfect method to find the second highest element, the first highest element, or the highest element, you can directly use the quicksort, and as per the convenience you can simply print the highest element or the lowest element from that. So quicksort is very efficient. You can tell the interviewer, like, I know this method and it is pretty much of a, let's say, the brute force. This is the method I know, so I just tweaked it into into several, let's say, into several methods, so to get our required result. So even though apart from not giving answer to the asked coding question, you have attempted what method you know, and it is pretty much easy to remember. So in the quicksort algorithm, we will define a function as quicksort, and we will pass the nums in the parentheses. Now what is the first thing we need to do is to check the length of that numbers or arrays. If it is less than 1, then we should directly return the nums. Means we are not allowing anything less than, we are not going to process the list having just one element. But because it doesn't make any sense, right, to check or sort a list having just one single character. Whatever the single character is it in the list, it is already sorted kind of. Then we establish a very crucial component of that algorithm is pivot. Now what is the pivot? Pivot is nothing but the middle of that whole list. Like if the number contains 5 elements, then the middle would be the third element. So how we get that middle is, we put the indexing of the list. We simply divide the length of that numbers divided by 2. Double, we use double backslashes to get the ceiling or the round number of the existing numbers list. Like what this specific what this line is doing is, it is getting the middle of that whole list, and this nums is just the list. So by this sentence, we are just simply pointing out to the middle of any list. Let's suppose it is of, if it is of 5, the length is 5, then it would be the third element. The length is 6, then it is somewhere between 3 and 4. If it is 7, then obviously it is fourth element or third element. It is just like this. So pivot is the first element. We have to mention pivot, like whatever the list comes here, we have to find the middle of that. Now let's start with the left hand. So list is divided into three parts: left, middle, and right. So if we establish a left, then left would be again a list of. Now we are using the list comprehension here. How we are using it? We are simply printing the x, then we are using a for loop for x in. Where we are picking up these elements from? Obviously from the nums. Then we are applying a condition if x is less than pivot. Now, whatever the central element is, the left should be the left elements should be lesser than the central element. It means we are arranging it in an ascending order. Similarly, the middle would be again a list comprehension of for x in nums if x equals to the pivot. Means whatever the middle is, the middle element should remain constant and they should be equal to the pivot. Now what is the right? Right is simply again a same list comprehension for list x for x in nums if x is greater than the pivot. Okay, I have forgotten the if condition. That's why it has given me a invalid syntax error. Now I am simply applying a simple if condition here. Then in return, what we are going to print is we are calling this function again. It is an example of recursive programming. But here we are simply passing the quick sort of left plus middle plus the quick sorting of the right. Now why we are not quick sorting the middle? Because middle is already what it is sorted. We are considering it. That's why whenever a list gets passed to this, it gets divided into several sections. It gets it pivot, gets the left, gets the middle. Means we are just breaking down the list to a single list. Unless and until it becomes a single list, we are just dividing it. Now it is not a divide and conquer method. It is a quick sorting. That's why the time complexity is on, and we are just simply parsing it. So that's how the logic works. So list gets divided on the basis of middle, again it gets divided and it gets rearranged, and then in the end we are merging it into the return statement, and the list will get formed in an ascending or sorted order. Let's say we have certain elements 11, 7, 5, 4. We might also include 0 and 1 and 13. Let's see how the quick sorting work here. Quick underscore sort and nums we are going to pass it. As you can see, the list is the list is now sorted and it is in an ascending order 0, 4, 5, 7, 11 and 13. Previously this has not been sorted. Now by this simple quick sort algorithm, what you can do, you can find the smallest element, you can find the second highest also by doing something. Let's say you can create another function and you can just simply print the second last element, or the second first element is the highest, second last element would be the second last element from the list, whatever it is, it would be the second highest element, and the first highest or the second highest first or second element you can again print by the simple indexing of whatever your list is. That's how you can simply tackle the problem if you don't know or if you don't remember the exact solution of the second highest number solution or any other subsequent questions. That's how it's going to help you in a lot of case scenarios, and it also would help you how to sort the list in an very time efficient way, very easy to remember. And also if the interviewer asks you to give the example of some sorting algorithms which are so fast apart from bubble sort or others, you can always opt for the quick sort. Thank you for watching.